Next topic, white noise random process. We'll see the definition. A random process x of t is called white noise process if the power spectral density is constant for all frequencies. That is Sx of f are all are notations, different notations. Sxx of omega with same meaning, right? Or SWWF or SWW omega or SNN omega is a constant, and the constant is denoted by n naught by 0. That is Sx of f etc or SWW of omega, which is equal to n naught by 0. In general, a random process x of t is said to be white noise process if its variable xti and xtj for I not equal to j are uncorrelated. That means covariance of x of ti and x of tj is equal to 0. That is Cxx of ti tj equal to 0. Next, autocorrelation of white noise. Rxx of tau or Rww of tau, right? We know Sx of omega, which is equal to n naught by 2 for white noise spectral density, which is equal to n naught by 2. Then we know Fourier transform of autocorrelation is spectral density. So f of Rx of tau, which is equal to n naught by 2, taking inverse Fourier transformation on both sides. So f inverse of f, it will become Rx of tau, which is equal to f inverse of n naught by 2. So applying inverse Fourier transformation definition, 1 by 2 pi integral minus infinite to plus infinite n naught by 2 e power I omega tau d omega. N naught by 2 is a constant, take it outside from the integral. So n naught by 2 into 1 by 2 pi integral minus infinite to plus infinite e power I omega tau d omega. That is nothing but n naught by 2 del tau, where del tau is direct delta function, right? Next, white Gaussian noise. The random process x of t is called a white Gaussian noise process if x of t is a stationary Gaussian random process with 0 mean. That is mean of x is equal to 0, mu x is equal to 0, and the flat power spectral density SWW omega is n naught by 2. Next, average power of white noise. E x square of t, which is equal to RW0. We know mean square, which is equal to autocorrelation at tau equal to 0. That is R of 0. That is what E x square t, which is equal to RW0, which is equal to n naught by 2. Instead of tau, you put 0, del 0, which is equal to infinite. Because del tau, which is equal to infinite, when tau is equal to 0, 0 otherwise. So white noise has infinite average power, right? Band limited white noise. A white noise random process having a non-zero and constant power spectral density over a finite frequency band and 0 elsewhere is called band limited white noise. Non-zero constant power spectral density over a finite frequency, right? That is the PSD, power spectral density of the band limited white noise, is given by SNN of omega, which is equal to n naught by 2 if modulus omega less than or equal to omega b, right? And 0 elsewhere, that is mod omega power spectral density over a finite frequency. That is the frequency lies between omega minus omega b to plus omega b. Then spectral density is n naught by 2, 0 otherwise. Then this is called band limit white noise, right? Thanks. We'll see you in the next video.